Hello, today I want to talk a little bit more about the analysis. I'm going to do something slightly more complicated than we did before, so we've moved on from the basics and we're moving up to the intermediate stage. I'm going to run up the analysis tool. I've got another simulator file that we've created specifically for this task, and I'll run you through configuring the file. I'm not going to load it into replay, but I'm going to go straight for the analysis. So I'm going to load the test. And we've got demo 2 now, and it's already gone straight to it because I've previously loaded it up before making this video. So, okay, I'm going to load the file. Again, pick a probe, pick probe 1, adjust the brightness so we can see it clearly, which we can. Now, put the speed on, and you can see, as you'd expect, we have an event on the acceleration and we have the same event on the way back down again. So we've got a simple 4,000 RPM through to 7,000 RPM acceleration and then back down to 4,000 RPM to demonstrate an accel decel. And we've got an event and we've got a second event this time. So if I zoom in, we can see that if you look along the line, this event is exactly on top of the dotted line, which means it's a synchronous event, and this is an event similar to one we had before. Again, between the lines it's an asynchronous event, so we've got a simultaneous synchronous and asynchronous event. Okay, so I want to take you through how we go about dealing with that. Now, you should have a theoretical Campbell or an actual Campbell for the vehicle you're dealing with. If you don't, then it's very much a trial and error, but assuming you've got that information, and most people will, you'll know, or I'll know in advance, that this is coincident with the third engine order line. With a simulation file, you can cheat, but you can't get away with this in general. I'm just demonstrating that it will come out on the 3.0 line briefly, but that's just because it's a simulation file and the signal to noise ratio is exceptionally good, and the way the simulation is generated. So as I've shown you before, I'll click on Announce Results and I'll clear those so it's gone. Yep, so that's just confirming that is a third engine order. But as I said, you need a Campbell, either theoretical or actual, and then you'd know where that coincides with the speed. So for the asynchronous one, I'm just going to click on it like I showed you yesterday, and it's going to generate an asynchronous response there. Okay, right, so what I'm going to do next is I'm going to zoom back out and I'm going to add some mode lines in. In fact, before I do that, I'll just make some adjustments to the display. I think we'll leave that at 10,000, but maybe we'll put that down to 1,000 so we can see the display a bit easier. There we go. And what I'm also going to do is tidy up some of these engine order lines. So I'm only really interested in, say, the first 5, so let's get rid of the rest. There is no upper limit on this, you can add as many as you want, up to 99. So okay, we've done that. So again, mode line creation, you can see it's there. So left control, I'm going to click, let go of control and click again. Just going to adjust this on top, which is what I've done. Okay, I'm going to remove this analysis result because that has no bearing, that's just a visual guide. It's not used at all in the calculation, so let's just get rid of that. And what I'm going to do is add a third engine order for this. Okay, so I'm going to create another one here. Left control, click, oh, did it again. Make sure the editor's live. So third engine order from there to there. I'm going to click there. I'm going to click there. Let go of the control. Click again. and I've created, as you can see, a line, mode number 2. Right, I'm going to close that, and I'm going to turn on show mode numbers just so I can refer to them. There we go. So mode 1 is going to capture the asynchronous response. Mode 2 is going to capture the synchronous response. So now I need to add some analysis areas, which I will do. So control, let's just pull that across so you can see. Left control click. I'm going to make that slightly bigger. Left control click. Okay. And we should be able to adjust these so that we're just slightly bigger. Again, you don't want to restrict it so you're in residence. You want to make sure you've got some room either side so you can do some extra calculations. I'm going to make this one the same size. Right, and you can see the highlight is on the accel and the decel because it will perform an analysis wherever these conditions are met. So this analysis here will have 2 outputs. This analysis will have 2 outputs. So I'm going to save the template, and I'm going to save it as demo 2. I'm going to save it as analysis 2. Okay, now I've got that saved. What's different about this file compared to the previous file is that these resonances both occur at the same time, which means they need to be taken into consideration. You can't analyse this without considering this one, and you can't analyse this without considering that one. The only time that's remotely not true is if one of these was very large and the other one was very tiny. Obviously the contribution from the small one to the large one is minimal, but not the other way around. So if that one was huge, this one was tiny, you must take this into account. But vice versa, you get close, but you don't want to because you don't have to. So how do we tell the software that they're at the same time? Well, it's easy really. I'm going to close that because I pulled it over this. So the third engine order is that line there, and I'm going to, that's for mode 2. So analysis areas, right, you can see here they've got 2 areas, 1, 2, got one on mode 1, which is this one, and one on mode 2, which is this one. I'm going to change that to an engine order, and you can see, so I obviously did it wrong deliberately, that it says it's going to use engine order 2. Well, we know that's not true, don't we? So what I'm going to do is click that to close it. I'm going to go back into the mode line editor, and I'm just going to move that up a bit. So there's more energy from engine order 3 than there is engine order 2 in there. I'm going to close that, open the analysis, and I'm going to refresh that to engine order 3. Right, once it's locked on there, it will stick with EO3, it won't change it. So I'm going to do a modal analysis on the asynchronous, but I'm going to combine that with an engine order analysis on the synchronous. So we've got a crossing of a 3EO and whatever this is. Okay, now I need to tell the software that it has to treat them as one. So I'm going to change that to a double. Clearly a double on its own is nothing, which is why, as you can see, instantly says no, you can't be a double, and it's changed that. So I should have done this the other way around. I'm going to change that to a double. Now I can then put this back to mode. Okay, right, so what we've now got is mode analysis on the async, double, engine order analysis on the sync, double. Now there's only 2 of them. It's quite easy maybe to assume that it'll treat them both the same. But if you look at the mode number, we've now got an extra column called pair. Now, what it basically means is area 1 is paired with number 2, and number 2 is paired with number 1. To demonstrate that, if I close that and add another mode line, again, left control click, let go of the control click, it's gone. Okay, add another analysis area in there. We've now added a third one, which is mode 3. So pull this back across, and we now see we've got 1, 2, and 3. Okay, the area numbers just refer to each distinct analysis. The mode numbers refer to the mode lines, so mode 1, mode 2, mode 3. They don't have to be in order. They don't even have to be sequential. What I wanted to show you was, if I set this up to be a double, okay, in here I can now select the pair I want it to pair with. So I can either do a double with 1, or I can do a double with 2, assuming I wanted to do it with 1. Let it go, and it's happy. Okay, if it wants to do an engine on a double. And again, you can add more and more modes. All I'm trying to say is that the pair tells it which other analysis area it is being paired with. I'm going to delete that. Right. Okay. I'm going to delete that one as well. I can click on it, press delete, and it's gone. So I've already saved this, so we don't need to save it again. In fact, I'll demonstrate. I can quick load it, and we're back to where we were. In fact, we're back to where we were, and it's wrong because I forgot to save it after I'd moved it. So double, double, mode. Right, and of course we've gone back to engine order 2 again because I forgot to save it. It's no problem. You can go around this loop as many times as you want. I've opened the mode line editor. You can click on the one you want to move, but I want to move this one, and I want it to have more energy on the third engine order line, which it does. I'll close that, load the analysis area, and you need to refresh the engine order. There we go, engine order 3. Right, I want to talk also about the analysis options. Some of these files are pretty big. Some of the analysis files are very, very big. So up to a file limit of 2 gigabytes, Multitool will output a CSV file in the same directory as the raw data. Okay, but once the file is calculated to be bigger than 2 gigabytes, it won't output CSV file for lots of reasons. It's very hard to read files that big into Excel or LibreOffice or whichever other Office package you use. So it outputs a raw file. The raw file format is published in our documentation. All our file formats are open. So you can then load that into MATLAB or whatever other package you want. You'd have to maybe have some specific requirements for a file that size to be of any practical use. Maybe you could reduce your analysis areas to get files a little bit more workable. But if you wanted to put the data out and post-work it in another tool, for instance, afterwards, then you're certainly free to do that. The data's formats are all open. So if you wanted to put an output per binary file, then you could click on this, and it would, if the file size was under 2 gigabytes, it would output this in addition to the CSV files, okay, not instead of. So under 2 gigabytes with this ticked, you get both. Under 2 gigabytes without this ticked, you get a CSV file. Over 2 gigabytes, you get just the raw, whether you tick it or not, and no CSV file. Okay. Right, I'm going to save that template and save it again. Okay, it's done. So what I want to do now is I want to do the analysis on let's pick the asynchronous one. Okay, again, as I said before, only 24 blades. This does absolutely nothing in this case. I've got too many cores, so I'm going to click perform an analysis. What this will do is it will do the area 1 mode 1 analysis. It will do the asynchronous response, and it will take into account its pair, which is this one here. Okay, and we're back. As I said, those analyses take slightly longer because you are mixing two different types of analysis on the same analysis, and I have set these quite wide. It's probably worthwhile just mentioning that on the mode lines, when you're doing a mode analysis, it will analyze the entire area. So covered by the analysis area. So obviously, if you can be sensible on your placement, then that will reduce your analysis times considerably. And for instance, not on the engine order, because that will make no difference, it just tracks the EO line. But for mode analysis, which we've got here, which is area 1, on mode 1, which is this one, the height of this will make a difference. Again, just be sensible. You don't have to be it's not critical, but get as close as you reasonably can, and your analysis will be seriously more quicker. Right, okay, so they only took a few minutes, but that's pretty boring watching that on the video. And I've got one for the accel, one for the decel. So what I want to do is while I was waiting for that to happen, I changed these types, and I'm just going to load a third analysis file. Okay, I'm going to look at all I did. It's exactly the same analysis, except I changed the types to singles for both of them. Okay, so what I want to do is I'm going to do the area 2 mode 2, which is this one, and I'm going to run that as a simple engine order analysis on its own. So I'm going to pretend this is not here. I'm just going to analyze that. Okay, and you'll see the difference in speed because the EO fits are a lot simpler to do. I will click that to go, and we'll just wait. It's done. And now it's on the decel, done. Okay, it's finished. So I'll close that. So if I go to the result files, okay, we've got 3 accels, 3 decels. And I don't know whether you noticed that, but it's clever enough to work out which one it belongs to. So the very first one we did is an accel, and it's highlighted this part of the file. If I click on there, it's highlighted the decel, and again accel, decel for each individual mode. So I want to just look at, in fact, well, I'll show you the mode one first. Let's view that. There's the mode response. What can I say? It's a simulator. There's the mode 2 response, which is the 3EO, and again, what can I say? It's a simulator. Now, what we're going to look at here, I'll just change this to uncertainty and speed. Okay, so you can see around the peak, let me make it, oops. That's done an analysis, I didn't want it to do that, but never mind, we're back again. Right, if you look around the peak, you can see that what we call quality of fit is very high. Uncertainty, very low. Response, lovely. Okay, peak value about 0.95, which is where it should be. Yep, okay. Again, the peak value's always got the red cross. If the red cross appears in what appears to be free space, that's because the data's decimated, and it isn't. If you just go in a bit further, you will see, oops, that it ties up. Oh, I got with the top point. There you go. Sometimes it gets a bit confused on speed because the data can go back on itself. Anyway, I will put that back. So what I was trying to show you really was high confidence, low uncertainty, lovely display. Now that was mode 2, okay, but we did mode 2 and we treated it as a single, and I want to open that file and see if you can see a difference. So we treated it as a single. So we looked at this, but we said that doesn't exist, it's not real. And look at the difference you get on the display. This demonstrates why you need a proper Campbell, or you need some understanding as to what's going on. But what you can figure out when you're not expecting. There you go. So confidence has dropped considerably, and we'd say at this point there's something very wrong there. Okay, the uncertainty is still fairly low, but when we do analysis, we look at how much energy is available, how much vibrational energy, and when we do a fit, we say what percentage of that vibrational energy have we accounted for. So if I was looking at this, I would say because that dips, we are not accounting for all the energy. There is something else going on at that point, and you really would not want to use this, even though the response is still fairly nice to look at. It's a simulator, as I keep saying. Clearly something's wrong, and that's what this green confidence level gives you. It says, no, you haven't accounted for all the energy that's around. Something's wrong, and we know what something's wrong because you need to take into account this one. And if you look at the correct file again, that's what you get. Very confident we've accounted now for all of it. So even though I've done analysis on the third engine order, it has taken into account this, and I've just proved that by showing you the two different results. If we do a 3EO analysis on its own, we get very poor quality. In other words, it says, no, there's something else going off, you need to figure out what that is and set the analysis up for it. But when we do, and we add in the asynchronous, so we've got a synchronous and asynchronous occurring at the same time, we are now very confident that we've got those numbers right, because we're saying we've accounted for all the energy and the fit is very good. Right, well, hopefully that's given you an insight into maybe something slightly more difficult with the editors. I've covered these before. I don't think I'm necessarily going over that again, but maybe once more around the analysis as a summary. I'll move it just to one side so you can see 3EO. Okay, we know that because we've got a Campbell. We would have, but it's a simulation file, either theoretical or actual. You need a Campbell, otherwise it's guesswork. Okay, and I've created two mode lines, 1 and 2. Okay, area 1. Now it's not always area 1 mode 1, area 2 mode 2. I just did it in that particular order. So area 1 is on mode 1, area 2 is on mode 2. So we've got two separate analyses because they're on top of each other in speed. We know that they should be doubles, and I'll just correct again, right click, and the templates that are in the data directory are instantly pulled in. So if I right click the mouse and then left click to select, obviously, if, as I covered yesterday, if you've got multiple files and you want to perform the same template analysis, you just put this in a folder called common templates. Have a look at yesterday's video if you want to see how to do that. But I'm going to pull the proper analysis back up, which is 2. Go to analysis areas. I'll just cover the D cell up, and you can now see what I was trying to do. So mode 1 is asynchronous, and if I'd left the orange line on, you would see that, but I deleted it. So mode 1, asynchronous, mode analysis, and mode 2, area 2, third engine order, synchronous analysis. Okay, both done as doubles. I've told it that this doubles pair is area 2 and this doubles pair is area 1. So you can have as many as you want in this list, and that's for another video maybe. Okay, and it's just a bit of confidence that it's automatically decided that it wants the third engine order for this. As you saw me correct it, if you moved it onto another engine order, or there's more energy from another engine order in there, then it will pick that instead. It's just a quick case of adjusting it and you're good to go. There may be one last thing I probably should show you, because it can be slightly confusing because I've got the area and the mode with the same number. I just want to cover one last time. The area is the analysis area. The mode is the mode line that the analysis area is contained in. Each area is unique, but you can have more than one area in a mode. I'm just going to create one more just to show you that. So control click. Okay, we've created one. You'll notice there's a bit of an error here, clearly because the area has gone outside the bounds of the file. So I'm just going to drag that back in to there. Let it go. Okay, so, and these areas can overlap as this does. That's perfectly fine. They're not interacting. They're on the same mode. So if we now look at the display, you'll see that I have, and these are sortable. So area 1, area 2, area 3, and area 1 is on mode 1, area 3 is on mode 1. So that's the difference between the two columns. So if I go to mode 1, I can see that I've got areas 1 and 3. So you can sort it out pretty much however you want. I just wanted to make it absolutely clear that the area numbers are unique and you can have more than one area in a particular mode. Okay, and at that point I'll definitely leave it there.